All right, here I am in AutoCAD, and today we're going to do a video on designing roofs. That's not something that there's a lot of resources on YouTube, and I want to help you guys get to the point where you can draw a roof for your modified ICF house plans and then take them to a truss manufacturer and have them actually build trusses based on your plan. So you're not going to be designing the trusses themselves or anything like that. You're just going to kind of be laying out how the valleys line up and how the hips line up and how to do side elevations and stuff like that, and then the actual truss manufacturer can take that information and turn it an actual truss layout. So let's get started. For simplicity, I'm not really going to be using my actual drawings. We'll make some samples and build a roof off of them. Before we start, it's important to understand some terminology. When you're looking at a roof, I'm just going to draw a fake little building here real quick. So this is called a gable end. So when you see a slope like this, that's a gable. The alternative is a hip, and that's easier to see from the top. So I'm going to draw one of those really quick. So let's draw, this is in plan, looking down from the top. So if you have a gable roof, this would look like, this would be the ridge line from the top. These would be the eaves. And then if you have a hip roof, instead of you seeing the side of the roof over here, the sides of the roof terminate at 45-degree angles. So as you can see, the roof is more of a pyramid shape. These roofs are becoming more popular. They're a little more resistant to wind, but I don't know. I just don't like the look of them. So my house will ultimately be designed with a gable roof, but I'll run you through how to build a roof for both. Now, this is a really simple structure. This is just a rectangle. So I think you could have figured that out on your own, but I'll go through how to do it when you have like a T-shaped house or an L-shaped house or something more complex like that. What's particularly more complicated is when the roof pitch between the main roof and the roof that's going to be intersecting with it is two different pitches. And you got to do a little bit of visual math to figure out how to do that. No calculations, just kind of drawing some construction lines in AutoCAD. So first things first, let's talk about roof pitch. Roof pitch in the United States is described in terms of number of inches of rise per 12 inches of run. So common roof pitches are like a 6 pitch. You can buy standardized trusses and pitches up to like an 8-12. But if you want anything really steep like a 12-12, like you might see on a Cape Cod, you'll have to have those custom ordered. And really, getting trusses custom ordered is not really a big deal. They're not that much more expensive from a custom truss manufacturer. You'll just have to wait a lead time. So take that into account with your build schedule. So I'm going to draw up some roof pitches here and show you how to draw a roof pitch so you can kind of look at how they fit on your house. So first things first, let's draw a sample house. Let's say our house is 10 foot wide or 10 foot tall, and on an end it's say 40 feet. So imagine this is the side of your house. We'll also draw it from the top real quick because we'll need that later. So again, and a lot of times in AutoCAD you don't actually have to type in numbers. You can just kind of point at things, and the snaps will help you out. So this will be the plan view, so the view from the top. It's got to be the same width, and then we're going to make it 60 feet long. So this is kind of an elevation view from the side, and then this is a plan view from the top. You can hear my computer starting to kick up a little bit. So let's look at the elevation view real quick. So in order to make a pitched roof, you know, kind of like this, well, you can do that, but we want to get a roof that's actually, you know, a pitch you can buy. So the easiest way for me is to kind of go off to the side and make a line that's 12 feet long. And let's say we want to make a 6-12 pitch, and then I go vertical and make a 6-foot line. And so now I've got a line here that is exactly the right pitch for the roof I want. So say we want the eaves, which is the overhang of the roof, to be 18 inches. I'll click on the edge of my building here, and I'll drag out this way, and I'll say I want 18 inches. It seems to have put an angle in here, so I'll set 180. And, oh, that didn't work. Let's try again. So you get your snaps kind of lined up, so it snaps, and then you can say 18. And now I have an 18-inch horizontal overhang off the roof. So now what I can do is I can grab this line over here. That's the right pitch, and I can just snap it to that roof eave there. So now I have a roof that's my 612 pitch and has an 18-inch overhang. Now to get this across the roof, so I'll just grab the whole thing. I'll type MI for mirror, and then I'll click on the center of the roof and make a mirror line. And now I've got the roof on both sides. And then to connect these two lines, I'll just hit F for fillet, R for radius, and then I want to make sure my radius is still set to 0. And then I can just click on these two lines, and all of a sudden I've got my roof with a 612 pitch on it. So that's cool. But maybe I feel like I don't want a 612 roof. Maybe I want to see what a 412 looks like. So in a lot of cases, I'll just draw that directly over what I've got. So what I can do is I can delete this line that we'd use to make the 612 pitch. And instead of going up 6 feet, I'll go up 4 feet. So now I'm going over 12 feet, up 4 feet. And if I draw a line here, I have a line that's at a 412 pitch. So I can grab that, I can move it, and I just snap it to the same place. I can do my trick with the mirroring again, and then filleting to get the roof in. And so now I've got the outline of what would be a 612 pitch, and then the outline of what would be a 412 pitch. Some other cool things you can do while you're here are maybe your neighborhood has restrictions on how tall your house is allowed to be, and it's probably not going to be a problem for a single-story house, but I can just type DI and measure from the base of my house all the way up to the ridge line. So if I had a 412 pitch, it would be 17 foot 2 inches from ground, finished grade, to ridge line. And if I had a 612 pitch, it would be 20 foot 9 inches. So that's just kind of convenient. There's not really much to see if you do that in plan. Remember, we have an 18-inch overhang all the way around our house. So what I'll do is just type O for offset, say 18 inches, because that's how much we want to come off, and click my main line and then come out. And so I'm going to leave this interior line here. Sometimes I'll go through and grab it and change it from a continuous line to a dashed line, just to signify that it's the interior wall. And if you notice, you can't actually see that it's dashed. That's because you have to go under properties and change the dash scale. Let's see if I can even find it. Maybe I'm lying to you. Oh, see line type scale. Change that to like 10, and then I can start to see it and change it to 100. And now you can definitely see that's dashed. So this represents the exterior wall. And then the solid line represents the actual outline of the roof. And then if it's a gable roof, all I got to do is draw a ridge line, and you got your plan. If I wanted to draw a hip, roofs are almost always 45 degrees. So what you can do is you can click on one of these corners here and have it snap to 45 degrees like that, or you can hit tab and type in 45 degrees manually. And then I just draw a line. I usually overlap a little bit, and then I click my line. I type MI for mirror. I mirror across the ridge line, and then I type TR for trim. Hit enter again to trim all, and then you can trim the ridge line away. And so now you have what would look like a hip roof. And you just repeat this for the other side to get the full hip. With a hip roof, you might want to look at what this looks like from the other elevation. So in that case, we'll just draw another side elevation here, and I'll catch this line here, and I'll catch that line there. And remember, our building was 10 feet tall, and so now this is an elevation, but it's kind of sideways on us. In AutoCAD, you actually can flip the view. I'm not super familiar with that. I don't like to do it very often because I kind of get lost. But with a hip roof, you draw the ease van really quick. And then this is kind of a technique that you use pretty frequently when drawing your elevations for your roofs is you actually need multiple views to be able to figure out the height of things. So say your hip roof is the 412 pitch. I'll just draw a line really quick from the top of the ridge line to the top plate. And now I kind of have a measuring stick that I can move and rotate, and that'll tell me when I'm in this other view what the elevation of my roof actually is. Okay, so let's use that mirroring trick again. I'm going to mirror across the center of the building. I go L. And then we can rotate this view so it's actually a little more appropriate. But now you can kind of see your house from your two elevations from the side, from what's called the gable end, and then from the front. So this is the 4/12 pitch, and as you notice, it looks really it's really low slope. You don't really want to get super low slopes because they have trouble shedding rainwater. So a 6/12 pitch and up is kind of a better option. And again, we can draw the hip roof equivalent. So again, it's useful to have our measuring stick. So we'll draw a measuring stick from the ridge, the peak, to the edge of the wall. And then I can just move this measuring stick to here and then rotate. And then I'll let AutoCAD find the endpoint of that line. And then we can use our mirroring trick again. And then we can trim. So as you notice from the elevation view, the angle of the roof is no longer 45 degrees. So that's why it's important to use that measuring stick technique instead of, just drawing a 45-degree line here. And that's kind of what I meant by visual math. To calculate that, you can do that with trigonometry, but it's a lot of work and you're likely to get it wrong. This is quick, anyone can do it, and it's spot on accurate. So far I've kind of shown you how to draw different roof pitches. I've shown you how to convert a gable roof into a hip roof. Let's get a little more complex here and go into drawing intersecting roof plans. For now, we'll stick with two intersecting gable ends that have the same pitch. I'm going to draw up a quick kind of T-shaped house, and then we'll go from there. Okay, if you guys are watching that, I have kind of an arbitrarily shaped house here. It's roughly 30 feet by 60 feet, and then it's got this 20-foot wide gable end at the front. And this is from plan again. So this is looking down on the top of the house. This is the roof outline, so we can actually take that, change it to a dash line. And remember, it was kind of hard to find the proper line scale, and so I'll show you a trick really quick. You can type MA for match properties. In AutoCAD, that's going to be paint, and then you click on the line that you want to be the parent, and then you click on the child, and it'll match the properties from the parent to the child, which is like really convenient if you kind of get a line the way you want it and you don't want to fiddle with all the properties again to get that line. So now we have the roof outline. So again, let's say that we want our roof to be 18-inch overhang. So I'll hit O for offset. I'll type 18 inches. And if you notice down here, it preserved my 18-inch offset from last time. So it says 1 foot 6 inches. So I'll offset, and okay, this is kind of a pain in the butt to do this one at a time. So one way to speed things up is to convert this from an individual set of lines to a polyline. And I think you can just hit join once you circle them all. And now if you notice, the whole thing is one object instead of individual objects. And the nice thing is when I go to offset, it automatically does the whole thing for me. And now, again, we don't want this dash line for the roof outline, so I can just type match or paint, depending on which program you're in, and I can grab one of the other roofs and then click this one. And now we have a nice looking roof outline. So now we have the outline of the roof. I'm going to actually draw the elevation views. So I can kind of grab this point, and I grab this point, and it reminds me that the building is 60 feet long. And then I type tab, and again, we'll say it's without a roof on it. It's 10 foot tall. I'm going to type L for line, and I'm going to pick up this line here. And I'll do the same over here. And so a lot of times it's good not to work with dimensions and just actually reference other lines, because you're more accurate that way, and it's a lot faster and you have less numbers bumping around your head. And then I'm going to draw the side elevation over here. So I picked up that point, and again, it's 10 foot, and right now it's rotated sideways, so it's be kind of confusing looking, but we'll fix that later. Sometimes I can't get it to come out to 90 degrees, so I just go over a little bit and then trim away the line later. Okay, so now we have two elevations and a plan view. So let's start with a simple gable roof. And gable roofs are really simple. All you gotta do is pick up the center line, the midpoint, and draw straight across. And then I can do the same thing over here. Pick up the center line and draw straight across. And what's really convenient is if the two pitches are the same, and in this example they happen to be, then the valley, which is the crease where they meet, is just 45 degrees. So I'm going to use the rotate command, shortcut RO, click on this point, and I want to rotate it 45 degrees. And I think AutoCAD follows math convention where positive angles are this way. So I want to go negative 45 degrees to go this way. Yep, that worked. Doesn't quite make it to the ridge line, so I'm going to go ahead and hit EX for extend. I'm going to hit enter again to use all lines as boundaries, and then click on it to extend it. And then again, same process, we just mirror it. So now this is kind of what the roof looks like from the top, and this line doesn't belong here, so I can hit TR for trim, and we can get rid of it. And so look at that, no math, we didn't have to figure out how high this point was. It just kind of fit there. Now let's draw the roof in an elevation. So again, we wanted an 18-inch eave, so I'm going to come 18 inches off this line. And that gives us a point over here. It's kind of invisible because the lines are laying over each other, but you can see it in if you have your snaps on. So to get that 612 pitch, we're going to go over 12 feet. We're going to go up 6 feet, and I'm just doing this off to the side so I can get this line here. That's the right pitch. I don't care about the length or anything like that. Now I'm going to grab it from this endpoint with the move command. I got to find that 18-inch line there. So there it is. I can delete this. I don't need that anymore. And then I can hit MI to mirror. Wow, we were actually really close when we mirrored. But now you've got that roof in elevation view. We still have to draw this main roof, and from this view I can't tell how high it is. So what I'm going to have to do is go to my other elevation, and this is common. You're kind of flipping back and forth between elevation views. So we draw our eave here. I shouldn't have deleted that line, but I can actually grab it. I'm going to copy because this line's at the right pitch. I'm going to rotate it. Rotate it 90 degrees so I can get it in the right orientation for the other view. And I actually need to mirror it so I can get it on this side. And notice I'm being careful not to rotate it anything other than 90 degrees so that I maintain that 612 pitch, but then I can just click the edge, click there, and it ends up where I want it. I actually don't, I'm going to try and mirror this from across this ridgeline here. Well, yeah, let's just do it. Mirror, and I can grab the ridgeline here, mirror across, I've got that. And then again, we'll use that fillet command to bring those to center. And now we got to figure out where this front gable intersects on this roof. Remember, don't forget your 18-inch eave here. And I'm just going to make, let's do the measuring stick. So we're going to make a measuring stick from here to here. And then we're going to grab this to figure out how high this roof would be in this other view. So there we go, got that there. Now let's draw the ridge line for that other piece. I'm not going to try and line it up because I can just trim later. And there we go. We got that front view. Now we got to get the main roof on this elevation. So we'll use the same kind of measuring stick technique. I'll grab that line. Got to rotate it. And now I can just move it over here. Okay, and then I got to make sure I don't forget that eave. Just make sure it lines up with the, oh, it doesn't. We must have moved something here. Let's see where this line goes. Well, I guess we're just no longer lined up with this plan view. I must have moved this at some point. And that's okay because the techniques we've been using aren't going to be affected by that, but it's just something to be careful of. And now I can just mirror this across the whole structure to get it on the other side. Then I real quick draw a line there. And now we have a complete roof plan for our slightly more complex roof. If you wanted a hip roof, like that's not any harder to add. We can just come off the corners here, and 45, the complementary angle of 45 is 135 if it's not referencing the right point for you. And then you can just extend. You can mirror across the ridgeline. You can trim these lines away. Then you can grab your two hip rafters, they're called. And I'll mirror again across the center of the building, and then I can trim. And all of a sudden, the plan at least is turned into a hip roof. Now we have to use our measuring stick again to figure out where this hip actually interacts. So that's where it meets the top of the roof. And then I mirror across the building, and then I go trim to get rid of all this other garbage. I don't need any more. Unfortunately, the trim command, I know there's some sort of option that will have trim delete segments for you too, but for me, if it's not trimming, it won't delete. And so it's kind of frustrating. I have to go back there and manually delete. But now we've converted that to Gable into a Gable that's intersecting with a hip roof. So that works for any size building. You just kind of use those measuring sticks, mirror, do that little technique where we're trying to get the 6/12 pitch. You could use any other pitch if you wanted to, a 12/12 even. You just go 12 feet up and 12 feet over. So that will cover probably 90% of roofs. My house in particular, the one I'm designing, has this front gable here is an 8/12 pitch, and then my main roof is a 6/12 pitch. And those same techniques for figuring out the roof pitch totally work, but for figuring out the pitch of the valley, you actually have to be a little more careful. So I'm going to draw up another sample house really quick, and we'll explore that. Okay, I'm back here. We have a demo house. This is in plan, so this is looking down from the top. And let's say that we want this main section of the roof here to be a 6/12 pitch, and we want these gables pointing to the front to be an 8/12 pitch. And that it complicates it a little bit. So let's go ahead and run through that. So as before, we'll use the join command to make this a single piece. I'll type MA or paint to capture this line style. I'll offset, and this time let's do 12-inch, not 12 foot, 12-inch eaves. Again, I'll use paint or match to convert that back. I got to get the center line of this because I lost it when I put these gables in, and now I've got the center of the roof, of the main roof here. Just draw a horizontal line. Again, I'm having trouble picking up that point, so I'm just going to overdraw and then trim away the excess. I don't need this point anymore. And then let's pick up the center lines of our gables. We're not really sure where they're going to end up on the roof, but I'm just going to go a little bit further back there. Okay, so now here is the confusing part. If you remember when we drew this roof over here, we just assumed that this valley was at a 45-degree angle. That doesn't work when you have a 6/12 pitch intersecting with an 8/12 pitch. What you ultimately have to do, and I always forget which direction it's supposed to go, is you have to make one line 8. So I'm going to say 8 foot because this is the 8/12 pitch. And I'm pretty sure that the line is just perpendicular to the ridge line. So you go up 8 foot, and instead of going over 12 foot or anything like that, I go over 6 foot because the ridge line it's intersecting with is a 6/12 pitch. And now I've got this angle, and it looks funky. It's not 45 degrees. Figuring this out with trigonometry would be really painful. Trust me, I've tried. But now we have the valley for how this kind of strange gable intersects with the main roof. Same techniques as usual. I just mirror across the ridge line. I actually have to extend this ridge line because it wasn't long enough. Then I can trim it. And I don't think there's any reason to save that. What I'm going to do is just go ahead and copy this across, because both of my gables happen to be the right size. So if you remember how we did that, we made a line, whereas normally if we're making a roof, we'd make always a 12-foot line, and then the height would be the pitch of the roof. So like say 6 foot to get that line. For these, when you have gables intersecting that are different pitches, you make one line in the direction of the first roof, and you make that line the length of whatever the pitch is. And in this case, it's an 812, so I make it 8 foot. And then you make another line parallel to the ridge line of the roof you're intersecting with and make it the same length as the pitch of that roof, so 6 foot. And then this angle becomes the slope of your valley. So it's complex, but once you kind of remember that, all of a sudden you can do any sort of crazy roof intersections. So this wasn't that bad. We've got the roof in plan. Let's drop the elevations really quick, and we're going to use measuring sticks to get all the weird angles and stuff like that. So I'm going to draw a rectangle for the size of the house. And I don't remember how long the house is. I don't need to. I'm just going to go ahead and pick up that point. And it's 10 foot tall. And we'll draw in our gable ends from the front here. And we need to remember to include our 12-inch eaves this time. And you know what? From this perspective, I can't actually tell how tall the ridge line is. So I've actually have to draw another elevation on this side. So our house is 10 foot tall. Don't remember how long it is. Oops. So look, I picked up the wrong point there. You got to be kind of careful. If it becomes too difficult, you can say E for escape and restart the line command. Try again. There we go. So we have a 12-inch eave. And then let's pick up this interior wall here. So even though this won't show up on the side elevation, it'll be helpful for us when we're building our roof. I want to break that line into 2, so I have a midpoint I can actually use. So now remember, this part of the roof is a 612, so we got to make up a 612 really quick. I'm going to go down 12 feet. I'm going to go up 6 foot. And then I've got that roof slope that I can just move into position right to the edge of the eave there. Now I'm going to use mirror, grab my roof, and this is why I split it. It's so that I can grab the center of the roof there and mirror and have it end up in the right location. Now I can do a fillet really quick to get those two together. So now I have the height of the main roof here. I can make a measuring stick. Got it. And let's delete this one because this one's not actually the right height. I'm going to rotate this guy into place. And there we go. Now I can just mirror this across. And we have our roof in elevation. So now we just got to draw on these gables. Remember, it's a 12-inch eave. And then we've got some sort of slope coming up here. I'm just going to draw it in place so I remember where this eave ends. Remember, this is an 812 pitch, so we got to go over 12 feet. Up 8 foot. And as you notice, it's a little bit steeper. So now I have an 812 pitch line. I can grab this guy. I can mirror him across. Oh, I don't have anything. I don't have a line to mirror across here. And so what I can do is just make a quick construction line here. And then that way I can pick up that midpoint and have it end up in the right spot. So we'll trim away the excess and then get rid of that construction line because we don't need it anymore. And then we just copy this over. I can either mirror it because I have a center point here, or I can copy. And yeah. Okay, and then I think the only thing that's left here is this part of the roof in elevation here. So we'll make another measuring stick, grab it, rotate it. And then don't forget the 12-inch eaves. So I gotta draw those in. And there, the the side of the roof there actually kind of takes care of itself. So I can rotate this just so that all the views are pointing upwards. But now we have all three views we need. We have the plan, the roof plan. We've got an elevation, and we've got another elevation. I was really just wanted to go over the basics of how to kind of get the rough structure down. You can go in later and draw in things like, the fascia. So you want like a 6-inch fascia board. And as you start to put these details in, it'll look more and more like a roof. But this is geometrically correct now. And you can actually take these views once you dimension them. I might do a video later on sheeting out drawings, but these are geometrically correct views that you can take to your local truss manufacturer. Menards even manufactures trusses through Midwest Manufacturing, so you can take it to them. They're just, I don't know that they're the best. They're probably the cheapest, but this is all you would need for them to go ahead and build you a set of trusses that you can drop on your house. So in quick review, I showed you how to do a rectangular house. I showed you how to do a gable or a hip roof. I showed you how to choose a 612 pitch or a 412 pitch, or really any pitch you want, by drawing some reference lines. I showed you how to make an elevation. I showed you how to find out where the hip intersects the ridge line in the elevation view. I showed you how to do an intersecting roof with Gable when the pitches are the same, and this is probably the most common scenario. And then I even showed you the really complex one where you've got two different roof pitches interacting with each other, and I showed you how to make reference lines that follow the ridge line of the two different pitches to get the actual angle of that weird valley. So that's it. Good luck with your plans. I know a lot of you guys got to be having to redraw your roof plans when you make modifications for your ICF house. This is something I had to do, so I figure might as well help you out. There's not a lot of good resources on this step online, so hopefully this was helpful. Also, if you want these DWG files, they'll be available on our new blog, valianteffort.blog. It's in the description. If you're not subscribed, make sure you subscribed and to follow our ICF build through the rest of this summer.